Hey everyone, welcome to the Foundry by Forge College for this explainer. Today, we're going to connect our previous work on finalizing the execution integrations report to the actual when and where of Solana's transaction execution. You know, if you've ever wondered how a blockchain can process thousands of transactions every single second without constantly waiting for data to arrive, well, you are absolutely in the right place. Today, we're exploring a brilliant piece of network engineering called Gulfstream. We're going to unpack exactly why it exists, the massive bottlenecks it completely eliminates, and how it essentially acts as the ultimate hyper-caffeinated logistics manager for the entire network. Okay, let's take a quick look at our roadmap. We'll start with an intro and recap, dive into the empty truck problem, unpack the express mail solution, compare the before and after, weigh the cost of speed, and finally wrap things up with our conclusion. All right, let's jump right into section 1, intro and recap, the when and where. So, building on what you already know from the Advanced Solana Concepts track about Sealevel execution, we are shifting gears from the how to the when and where. At its core, Gulfstream is a targeted mechanism that completely shifts where and when transactions are staged. Instead of every validator just sort of hanging on to transactions and passively waiting for a leader slot to officially begin, Gulfstream proactively pushes pending transactions toward upcoming leaders ahead of time. So the moment a leader is ready to build a block, they already have a warm, ready-to-go backlog of transactions sitting right there. No waiting, no twiddling thumbs, and definitely no awkwardly avoiding eye contact with the scheduler. Moving on to Section 2, the empty truck problem, also known as idle compute time. To truly appreciate this protocol, we kind of have to look at what goes horribly wrong when leaders are forced to just wait around. Imagine you've got this massive, high-performance sports car engine, right? But the fuel is arriving in unpredictable dribbles from a leaky eyedropper. That is exactly what happens with our three massive network bottlenecks: scattered submissions, brutal delivery latency, and mempool churn. Before Gulfstream, transaction submissions were scattered totally randomly, meaning a leader often started its slot without a ready backlog. Late arrivals drastically reduced throughput, and validators just wasted memory holding on to scattered data. Gulfstream systematically eliminates these bottlenecks by aggregating transactions near upcoming leaders and pre-delivering them. If you picture a panicked distribution center manager aggressively tapping their watch while a half-empty truck drives away, you really have to ask, how do we guarantee the truck leaves fully loaded? Because in a high-speed blockchain, an empty truck or a leader slot that isn't fully utilized is an absolute tragedy of wasted potential. That brings us to Section 3. The express mail solution. Let's look at a helpful mental model. The answer to our logistics nightmare is this really ingenious express mail network analogy. Imagine validators as local post offices and leaders as big city distribution centers. The packages are our transactions, and the trucks represent the scheduled slots. Now, before Gulfstream, you'd drop a package off at your local post office, and it would literally just sit there until the big city center specifically called up and asked for it. By the time the package finally made it over, the truck might have already left half empty, probably while the driver was on a lunch break. So Gulfstream acts as a dedicated express route that bypasses those standard wait times completely. It pre-delivers packages so the distribution center's truck can leave fully loaded and exactly on schedule. And because Sealevel dictates how many transactions can execute concurrently, pre-delivering these packages actually gives the leader time to assemble compatible sets of transactions that don't conflict with each other. It's kind of like loading the truck with perfect Tetris-level precision before the driver even turns the key in the ignition. Let's move to Section 4, before versus after in the transaction lifecycle. Let's look at a really concrete example, like a high-traffic, decentralized exchange swap. Without Gulfstream, we're relying on untargeted peer-to-peer gossip. It's like shouting your order into a crowded room, just hoping the right person happens to hear you. The leader wastes precious compute cycles simply waiting to hear about the swap. But with Gulfstream, nearby validators recognize the destination based on the leader's schedule. They use targeted pre-forwarding to send the transaction directly to the expected leader, which ensures a warm backlog is sitting there ready for immediate execution. Walking through the exact lifecycle steps, you can see how this entirely eliminates the waiting phase. Step 1, the client signs and submits the swap transaction. Step 2, a local validator checks the signature and basic semantics. Now, the magic really happens in Step 3. Instead of random gossiping, the node pre-forwards it directly toward the expected leader. So by Step 4, when the leader's slot begins, it executes instantly. It's an incredibly elegant solution to network latency. Instead of wasting up to 20% of a slot just tapping their toes and waiting for network fetches, the leader gets to spend nearly all its time actually executing. Just think about that number for a second. Shifting the uncertainty of network propagation to happen before the slot even begins reclaims a massive chunk of compute time. It turns a wildly inefficient waiting game into pure, uninterrupted processing power. Section 5. The cost of speed. Let's talk about the engineering trade-offs. Because implementing a lightning-fast express mail system across a global network isn't exactly free, right? To get this insane speed, the network accepts increased transient memory usage, extra validation work, and the absolute need to aggressively discard duplicates. I mean, if multiple post offices forward the exact same package, the distribution center has to do the extra work of identifying and tossing the duplicate. And what if a scheduled leader suddenly goes offline? Well, our express packages were just sent to the wrong distribution center. The network handles this by aging out forwarded transactions and requiring re-forwarding. So it's a calculated memory-heavy cost, but one that is absolutely worth it for those incredible throughput gains. Finally, Section 6, Conclusion and Next Steps. As you progress through your courses, this quote right here is the ultimate takeaway you need to remember. Gulfstream doesn't touch Sealevel's execution logic at all. It simply repositions the data beforehand to eliminate idle time. It provides Sealevel with the high-quality raw material it needs so it can do what it does best: schedule and execute in parallel. This conceptual foundation tees us up perfectly for our next lesson in the Mastering Gulfstream module, which is Gulfstream Architecture and Forwarding Mechanics, where we'll unpack the actual network heuristics. We are going to look at exactly how those forwarding decisions are made, how the network handles deduplication under the hood, and the underlying logic of time-to-live expiration. Until then, I want you to ponder this edge case. How do you optimize a blindingly fast express network when the scheduled delivery center suddenly goes up in smoke and goes offline? It's a fascinating engineering puzzle that we're going to solve together. Be sure to visit forge.college to dive deeper into Web3 and continue your programs with Forge College. Thanks so much for joining me on this explainer, and I will see you in the next one.